Hello, today we'll be having perfect squares quadratic equation. That's the topic on the board. Now, before we talk about this, we should explain the terms we have there. We have perfect squares, we have quadratic equation. So in this video, we are going to look at quadratic equations that are what? Perfect squares. Does it make sense? First of all, what is a perfect square? A perfect square is a number that is said to be a second exponent of an integer. So a perfect square is a number, we say that it is an integer that is regarded as the second exponent of another integer. Or you say that a perfect square is an integer that can be expressed by the multiplication of another integer by itself. Watch what I mean. If I say that 4 is a perfect square, now 4 being a perfect square, this is an integer, right? Now this 4 can be expressed as the second exponent, that's of another integer. Now 2 raised to power 2, second exponent of another integer 2. Does it make sense? Therefore 4 is a perfect square. Now 25 is a perfect square. Reason, because 25 can be expressed as the second exponent of another integer 5, the second exponent of 5, which means that 25 is equals to another integer times itself, which is 5 times 5. The same thing happening in 4, another integer times itself, which is 2 times 2. Does it make sense? Or we can say that a perfect square is a number whereby if you find this square root, it will give you a whole number, I would say a rational number. Is it clear? That the square root of 4 will definitely give us 2. The square root of 25 will definitely give us 5. Do you understand? The square root of, let's say, 9 over 16 will definitely give us, square root of 9 is 3, square root of 16 is 4. 3 over 4, a rational number. Does it make sense? So that's what we call perfect squares. So these numbers, for 4, 25, 9 over 16, they are all perfect squares. Very good. Now I've explained what perfect squares are. What is a quadratic equation? A quadratic equation, as we all know, is an equation whose highest power of unknown is 2. So all equations in this order, ax squared plus bx plus c equals to 0. It is a quadratic equation. So all equations in this order are quadratic equations. Does it make sense? So if I write something like y squared minus 4y plus 9 is equal to 0, it's a quadratic equation because the unknown y, its highest power is 2. Does it make sense? Very good. Now, how do we know that a quadratic equation is a perfect square? Do we have quadratic equations that are perfect squares? That's where this topic is coming from. Perfect squares, quadratic equation. This quadratic equation that I wrote here, is it a perfect square? That's the question. If I write another one, x squared minus 4x plus 4 equal to 0, is it a perfect square? That's what we are going to look at. So for you to know whether a quadratic equation is a perfect square or not, there are two conditions, and these two conditions must be obeyed for you to identify, or for you to say that it is a perfect square or not. Now the first condition that you should note is that the first term and the last terms must be perfect squares. The first term and the last terms must be perfect squares. Now which quadratic equation should we be using to check? Now let me use this quadratic equation to check. I have x squared minus 4x plus 4 is equal to 0. Is it clear? Now this quadratic equation, is it a perfect square? Let's check. The first term and the last term, the first condition says the first term and the last term must be perfect squares. Now square root of x squared is x? Yes. So x squared is a perfect square, right? Square root of plus 4 is plus or minus 2. The square root of 4 is either plus 2 or minus 2. But I'll take minus 2 because of the sign of b here. So in perfect square, I'll still do as in make a video that tells about simplification of perfect squares quadratic equation. In my next video, I'll do that. So I'm taking minus 2 because of the sign of b here, because of this minus that I'm having here. If I have plus here, I'll take plus 2. Does it make sense? So we're saying that the first term and the last terms are perfect squares, right? This is the first condition. Now the second condition says that when you've gotten this square root of the first term and last term, when you multiply them, that's x times minus 2 what will it give me? It will give me minus 2s abi. Then when you do 2 times that your multiplication, 2 times the product, which is 2 times minus 2s, that it should give you the middle term. That if it gives you the middle term, then the quadratic equation is a perfect square. Now, is it giving me the middle term? Yes, minus 4x. Therefore, this quadratic equation is a perfect square. Now, let me repeat. The first condition says that the first terms and the last terms must be perfect square, right? Now, the second condition, which I did not state earlier, but I explained, says that 2 times the product of the square root of the first and last terms must give the middle term. 2 times the product of the square root of the first and last terms, right, must 2 times it, the product, which this is the product. We got the product as this, abi. 2 times this will give the middle term. Now, is it giving the middle term? Yes. So, since these 2 conditions are obeyed, I can say that this quadratic equation, x squared minus 4x plus 4 is equals to what? 0, is a perfect what? Square. Do you understand? Now, let's check this first quadratic equation that I wrote. I have y squared minus 4y plus 9 equal to 0. Is it a perfect square? The first condition says that the first term and the last terms must be perfect squares, abi. Now, square root of y squared is y. Square root of plus 9 is plus or minus 3. But we'll take minus 3. Why? Because of the sign here, right? Now, the first condition has been obeyed, right? Now, the second condition, let's check. They say that when you multiply this square root of the first and last term, which is y times minus 3 is minus 3y. Now, then when you do 2 times the minus 3y, it should give the middle term. Now, 2 times minus 3y is minus 6y. But what are we having here? We are having minus 4y. So this quadratic equation is not a perfect square. For it to become a perfect square, we should have minus 6y. It should occur in the form y squared minus 6y plus 9 is equal to what? 0. Does it make sense? So by now, I believe that you understand what we mean by a perfect squares quadratic equation. That's, you know, the condition for a quadratic equation to be a perfect square. So tell me in the comment section whether this quadratic equation that I'm going to write down now is a perfect square. So be fast. If I have 25p squared, then if I have plus 1 equal to what? 0, then I have 5. Then I have minus 10p. Tell me whether this quadratic equation is a perfect square. Then tell me whether this one also is a what? Perfect square. So, which of these equations, quadratic equations, are perfect square? I hope you understand what I mean. Have a nice day. Like, comment, share, and follow Courses Academy. Bye bye.